I hope everybody's doing okay. Wanted to go over the review for the first half of this unit that we had started on Friday, that we had finished up on Thursday, before we go on to this new material. So for the first part in 4B1, we looked at a couple of different things. One of them was when we have coordinates, we are to plot the coordinates, figure out what the side measures are, and find the sine, cosine, and tangent of them. So that's what we're going to do right here. So if I plot the point, and I'm going to do B, but then I'm going to leave the others for you. But I'm going to plot negative 4, 2, and negative 4, 2 would land over in quadrant 2. My movement along the X was a negative 4, and my movement along the Y was a positive 2. So that's our leg measures. And what we want to do is use the Pythagorean theorem to find the third side. Okay, and the third side would be the hypotenuse. So we're going to use the Pythagorean theorem. I end up with the square root of 20. And I want to take that and simplify it. So 4 times 5 is 20. And I can simplify the square root of 4 to be a positive 2. So 2 square root of 5 is the third side for this particular coordinate. So now we want to just name the sine, the cosine, and the tangent. And remember, our radical is going to be in the denominator on 2 of them. We're going to need to rationalize that. So I'm going to give myself some more space. Okay, so for the sine of this angle, and remember the angle is always at the center, it's the opposite over the hypotenuse. Okay, now right off the bat I can tell 2 divided by 2 is going to be 1. So that's really 1 over square root of 5. And then to rationalize the denominator, remember we multiply both top and bottom by that denominator, or in other words, the radical moves to the top and comes out in the bottom. Okay, so that's my sine. So for the cosine of this angle, we are doing adjacent, which is a negative 4, over the hypotenuse. And right off the bat, I'm going to go ahead and reduce that to 2 over square root of 5. And then again, remember our radical moves to the top and comes out in the denominator. Okay, so there's our cosine. Our tangent for this angle is opposite over adjacent, which reduces to negative 1/2. So the next section is talking about stating the sine, cosine, and tangent of quadrantal angles. And so remember we named all of our quadrantals. 1, 0 was at 0 and 360. 90 degrees was 0 and 1. 180 was negative 1, 0. 270 was 0, negative 1. And these are our unit circle values for the angles that are on the coordinate, on the axes. Okay, so we're just going to look at this one. So if I wanted the sine, cosine, and tangent for this particular angle of 180 degrees, then sine, remember, is y over r, cosine is x over r, and tangent is y over x. And remember, in a unit circle, the radius is the distance from the center of the circle. And in this case, it would be a distance of 1. Okay? So for 180 degrees, or pi radians, the sine would be y over radius of 1. So 0 over 1, which makes sine 0. Our cosine would be our x value over 1, which gives us a cosine of negative 1. And the tangent would be our y over the x value, which gives us a tangent value of 0. So go through and finish the other 3 that are listed here. Okay? And remember, you can pause this anytime. Okay. So for the next section, we were to draw a triangle according to the constraints. So we want to look and see where should this triangle land in our coordinate plane. All right, for this value, cosine is negative, and because this is a reciprocal of sine, sine is greater than 0, so sine is positive. Cosine is negative in quadrants 2 and 3. Sine is positive in 1 and 2. So the quadrant they have in common is where that angle is going to land. Okay? So here's our angle. The adjacent is 2 because it gave us cosine, and the hypotenuse is 7. Now, because this is in the second quadrant, my x value is the negative, my adjacent. So now we need the third side. So this is a leg. So if we use the Pythagorean theorem, I'm just going to put it up here. A squared plus b squared equals c squared. Then we're going to take 49 and we're going to subtract 4. So a squared is the square root is 45, and we're going to take the square root of both sides. Now 45 can be split up into 9 times 5, and 9 can be split up into 3 and 3. So a is 3 square root of 5. Okay, so that is our opposite side of our triangle. Now we want to find the other coordinates. So it gave us cosine. We're going to find sine and tangent. So the sine of this angle would be opposite 3 square root of 5 over hypotenuse. And then the tangent is going to be opposite over adjacent. So that's our sine and our tangent. So you are determining what quadrant should the triangle be located in, then labeling the parts that you have, and then finding the third side before you name the values. Remember, anything can be made a fraction by sticking a 1 under it. Okay, so I'm going to leave that other one to you. Alright, and then for this next one, it says draw a diagram and state the sine, cosine, and tangent of the quadrantal. So this is a quadrantal value for both of these, and I'm going to do the second one. Okay, so if we just remember our values, okay, just remember what they are. Just going to label them. All right, this is saying the reciprocal of sine. So this is sine. Okay, is undefined. So that means it had to have a 0 in the bottom. Okay? In other words, for the sine function, we would have flipped that. It would have been a 0 and a 1. It also gives you a constraint here where it has to be between negative 90, which is this way, and positive 90, which is this way. Okay? So, if the opposite side, or the y, is 0, y is 0 right here at 0 degrees. And that would be the angle who has a cosecant value of undefined. Okay? So you try the 0 one. Alright? And then the next thing is without a calculator. And it says state the exact value. So what you need to do in this section is be able to determine where do these angles land. Okay? So for a negative 315 degrees, that would go clockwise, and we'd be in the first quadrant, okay? And we are how far from 360? We are 45 degrees from 360. Now, a 45-degree triangle has the same values no matter where it's located, okay? The only difference would be if it were in a negative area, then we'd have to have negative values. But if we look for the sine of this angle, the opposite is 1, the hypotenuse is square root of 2, so the sine will be square root of 2 over 2. So plot the angle, figure out the reference angle. The reference angle is 45 degrees. And then label your triangle and find the value they want. Now I'm going to do this one that is with radian measures, okay? So this one again, we got to think fractional, or you can change this to degrees if you would like. But 11 pi over 6 would land here, and we are pi over 6 away from a whole circle, okay? Now pi over 6 is the same thing as 30 degrees. So I know that opposite of 30 degrees is 1, adjacent square root of 3, and the hypotenuse is 2. Because of where this is located, the 1 or the y value is a negative, okay? So if they want the tangent of this angle, they want opposite, which is negative 1, over adjacent, square root of 3. So our tangent is negative square root of 3 over 3. Okay? Alright, and in the next section, trying to finish this in 15 minutes. The next section is to find all the angles that have this value. And remember, there's possibly 2 areas where we have these values, okay? So, if you think of this being the reciprocal of tangent, tangent is negative in quadrants 2 and 3. And so the angle that has a tangent value of 1 would be a 45-degree angle in both of these areas, okay? And so we need to name this angle, which is 180 minus 45, so 145 degrees. And we need to name this angle, and that is 45 degrees from 360, which is 315 degrees. So each of these will have 2 angles. Determine what the function is, the main function, sine, cosine, tangent. Decide where this angle is positive or negative, or that value, and then determine what your reference angle is and name the 2 angles. Okay? And then number 7, it says with the calculator, solve the equation using degree and pi radians and make a sketch. So I'm asking you to use the calculator. To do it in the calculator, remember, we look, if it's on both sides, we use the reciprocal, and we reciprocate the value. So you're going to put in your calculator sine inverse of 1 over 1.783. I get about 34 degrees. So 34 degrees would be quadrant 1. And then I want to change this to radians. So pi radians. So I'm going to multiply it by pi over 180. And all I'm going to do is reduce 34 divided by 180. So remember, change it to a fraction. And we get 17 pi over 90. So you have your degree measure and your radian measure. So these will be easier because they are the basic functions, cosine and tangent. Do your best on this, and then tomorrow we'll look at the completed packet. I'll get you to look at it, check your work, and then give me any questions that you have.